So today we're looking at scale diagrams, very similar to scale factors yesterday. Okay, and for scales, you use those for maps. We also use those for drawings and models. So just like yesterday, we determined whether the image was reduced or enlarged. Okay. So today's scales will also tell us whether the image has been reduced or enlarged. Scales can be converted into scale factors to calculate dimensions of models or drawings of actual objects. So we refer to models and drawings using just one word, diagram. Okay. So the diagram is going to kind of encompass both of those when we're using that. So scale is just a comparison between the actual size and the diagram. It can be written as a ratio, like 3 to 4, as a fraction, 3 over 4, or as a percent, 75%, or 0.75. In words, we can write it as 1.32 tells us that 1 centimeter of the diagram or model, whatever that happens to be, represents 32 centimeters of the actual object. So as a scale, so as a ratio, we're looking at diagram to actual. So you're going to hear me saying this a lot, D dot dot A. Okay, dA. As a fraction then, we're going to take this D dot dot A and we're going to change it into a fraction by pushing the D on top. So it's going to be D over A. Okay, I'm just remembering D over A is very important. It'll help us set up our ratios properly. We always reduce so that the smallest measurement divides to 1. That's one of the rules. And both measurements must be in the same units. Now there's of course one exception with decimals. Textbook's a little wishy-washy on this. Okay, but let's start with some examples. Say we have a scale 45 to 90. We want to divide it to 1. So you're going to take your smallest number, 45, divide it by itself. Now these are just like fractions. So you have to divide the other side by 45 as well. And so we'll get 1 to 2. So you're going to take your scale, put in the lowest terms, just like you would a fraction. Okay, a lot of fraction skills here. Another example. Okay, say we had a fraction. Let's say it's 5 to 2. So this would then be 5 dot dot 2. So to put this in lowest terms, we divide both of them by 2. So this becomes 1 to 2.5. Now sometimes they don't like that. Okay, sometimes they don't mind. Because of the decimal, they don't like decimals and ratios, just like we don't like decimals and fractions. So we'd actually multiply both of these by 2, and then we would have 2 to 5, or 5 to 2, sorry. Okay, and now there's going to be no decimals. Okay, and that's kind of the best way to have scales. Although when you buy models, you see all the time that there's decimals in there. Okay, so don't get too freaked out about that. Okay, it's a good skill to have, and then you'll do in your homework and it won't make sense. It's because they took a decimal out of their scale. Okay, so let's practice this a little bit. A couple practice questions. Diagram measures 4, the actual is 12. Start by writing the scale as D dot dot A, then substitute in your numbers, and then put in lowest terms. So the diagram is 4 to 12. And it's both centimeters to centimeters, so that's okay. Lowest terms then, 1 to 3. So which one has the bigger number? Diagram or the actual? Actual. So looking at the scale, which one's larger then? The actual object's larger. Okay. So your scale number will tell you which one's larger. Try the next one. Go. Okay, so again, diagram to actual. This time it's a model. 22 to 8. Lowest terms then 1 to what? 2.75. Do you guys know how to get 0.75 out of a decimal? Well, it's going to be 3/4. So multiply by 4. Okay, multiply by the denominator. So then we get 4 to 11. Okay, so then we have no decimals. Okay, so that's a little tricky. Which one's larger? Diagram's larger because 11 is the diagram number, it's bigger. Okay. Next one, now we have units which are different. That's a problem. So you can fix them at the beginning or you can fix them at the end. I'll show you both methods. Right here I'm going to fix them at the end, so divide by 9. We get 1 centimeter represents 3 meters. Now you can use that in math, but it's not proper to have your scales having different measurements. So we're going to then convert this to meters, so meters to centimeters, 1 to 300. Now we're in the same units. If you wanted to convert it at the beginning, you could have 27 meters to 9 centimeters, 2,700 to 9, so it's going to be 300 to 1. Okay. Any questions? All right. So sometimes you're going to get some easy math, sometimes you're going to get some harder math. We're going to start with the easier math right away. Okay. Here we have a diagram of skateboard. Scale is 1 to 14. Whenever we're going to do some calculations of some actual lengths or a missing number, you want to turn them into fractions. So diagram over actual. So we're going to write the scale as 1 to 14, and it's going to equal another fraction. Now we know the diagram number is 5.5. So that's going to go on the top of the fraction because it's d over a. The bottom number is the actual length. We're trying to find that. So we can write the letter x, we can use a question mark, you can use a little box, whatever you want. Now this one's so cooked up, it's so simple. Use your equivalent fractions idea. Here we have 1 to 5.5. So what do they do to get from 1 to 5.5? Times. So here you're going to have to do times 5.5. What does x equal? Grab a calculator for this. You're going to need a calculator. 77 centimeters. So you can say the skateboard is 77 centimeters. Okay. Not bad. Okay. So for the next one, you're going to set up two fractions again. One, remember, it's diagram over actual. Okay. So use the scale to set up this fraction, and use this number to set up the other fraction. Go for it. Okay, so we're looking 1 and 9.2. Here's, you caught a salmon. That means that 46 centimeters is the actual number. So it goes in the bottom of your fraction. You want to find the length of the diagram, so x goes on the top this time. Okay. So there's a couple different ways of doing this one. Basically, what would you do to go from 46? What's 46 divided by 9.2? 5. So you divide by 5. So if you go in the other direction, then you would multiply by 5. So x equals 1 times 5. Okay, x equals 5. And so you can say the diagram is 5 centimeters. Okay, we have the same units. Now, scales is a little cooked up, isn't it? Show your fractions. Please write those down for showing your work. We're going to see fractions tomorrow that aren't as cooked up, so we're going to be doing a little practice with them at the end today on how to solve any proportion. But ones with a 1 in it are a little more cooked up. Okay, we're going to go into more details later with that. So social studies teachers often use scales with the maps. Here we have the distance from Dawson City to Whitehorse. It's 540 kilometers. The map, it's 3 centimeters. Okay. So on the map, 1 centimeter represents how many kilometers? So let's write down what we start with. 3 diagram dot actual. So 3 centimeters represents 540 kilometers. So what do we have to do? 3 to 1, divide by 3. So we have to do the same thing to the other side. Use calculator. 180. There we go. 1 centimeter represents 180 kilometers. For the scale factor, they like them to be in the same units. Okay. Now, typically on maps, they're going to do the same units. So that's why you get some huge numbers, like 1 centimeter represents 45 million centimeters. And really, it's 1 centimeter represents 45 kilometers. Okay, and when you're doing the math, that's usually what you change it to. But they always give you the scale factor, okay, which usually we call scale anyways. We kind of confuse those up a little bit. So, 1 centimeter represents 180 kilometers. How many meters is that? How do we go from kilometers to meters? Times by 1,000. So we just have to add 3 zeros. Okay. Then 1 centimeter represents how many centimeters? So this is meters. How do we go from meters into centimeters? Times by 100. So then we're going to add 2 zeros on here. Use some commas to help you separate it. And so now you can say 1 centimeter represents 18 million. Okay. Notice they're commas and not decimals, Nadia. Any questions? Okay. So, you're going to get some proportions that are not easy to solve. We're going to practice this a little bit. So we're going to use proper algebra rules. So what we're going to do is we're going to cross multiply. Instead of dividing by x, we bring it up and multiply by x. We're going to do the same thing on the other side. Instead of dividing by 4, we're going to bring it up and multiply by 4. So we get 9x equals 40. And then x equals 40 divided by 9. 1 decimal place, please. 4.4. Okay. Okay, solve the next one. Go. And so we get 5x equals 77. X equals 77 divided by 5. What's that? 15.4. Good. Any questions? Now, when x is on the top for this next one, you don't need to bring the 21 up and multiply it. Because if we got 21x equals 36 times 15, well, the next step is to bring it back down and divide by 21. So you don't need to move the 21. You're welcome to. You'll never get it wrong, ever. But for some cases, all we have to do here is get rid of this divide by 36. Okay? And get 36 times 15 divided by 21. Okay? Go ahead, solve. $25.7. Okay. Go ahead, do the next one on your own. $71.0 equals x. Okay. Any questions? Now, I kind of showed you two methods. This one will work for absolutely every question, right? You're just cross multiplying, doing the opposite of the division that's shown. It'll work for everything. But, like I said, some of the questions, like over here, they're going to be pretty cooked up. You might want to solve them this way. Doesn't matter. You will tomorrow absolutely need to do the cross multiplication. It works for everything. It's up to you though, right? You can use a combination today. I'm okay with that. The more skills you have in your toolbox, the better you are. Any questions? So one thing to keep in mind for your homework is you're going to have to measure items. Okay? Try and measure in millimeters if you can, or 5.2 centimeters if it's in centimeters. Okay? Questions, comments, concerns?